Right, yeah, on that same JFET circuit I was doing in the last video, you noticed that they had this error in it. Well, as it turns out, if you're looking at the current, um, on this channel 2 waveform, which is what I'm measuring um, the voltage across the sense resistor, the 100 ohm 1% resistor there. You get this kind of offset. It never quite bottoms out, even though the thing has got to be off. I mean, because you can clearly see. And plus, I don't know why the hell they don't have frickin' cursors available in this XY mode. This has been like an early feature of this, since for the last 10 years. They still don't have that. Again, you could say, hey, it's a cheap piece of test equipment, but hell, it costs you as much as an entry-level Rigol scope to buy an analog discovery, and these days. So there's really no excuses for there being software bugs in it like this. Um, these guys are doing a good job. Don't get me wrong, but geez, they should try using their own test equipment every now and then. They know where the bugs were. Um, but this has an offset in it, and you see that's not flooring our curve like you should see. Um, what I did to correct it, is I went over to the channel 2 and I just decided to increase the resolution to see what would happen. Um, and voila, that corrects it, taking it down to 200 millivolts and increases the resolution. There's a lot of noise, and again, part of this is probably coming from my little setup here, maybe, but that's to be determined. But the fact of the matter is, that produces a nice little curve there. Just by because this isn't displayed on this curve. It's where the math waveforms data comes from, but it's not the actual an actual plotted curve. So that's why I could do that. Because I just really hate how they have this tied to this, to where if you want to modify this thing, you got to do it over here, which screws up your waveforms, so you can't see it. This should be still totally independent. The scales of this and everything should be totally independent of this. These should not be connected like this. It really just makes it screwy trying to figure out what the hell's going on. Talk about not using your own tools. Again, know a lot of scopes that have XY modes do it that way, but again, that's why copying other people isn't always the best thing, because you also copy their mistakes and bad ideas, and this is a great example of that. Oh, well, we're not going to mess, because this is the only excuse I can come up with. Having it this way this long. Analog Discovery's been out there for, certainly at least 10 years, and gone through a lot of software iterations, and, but yet we still have this. No cursors and no independent control of this XY, versus control of the scope. Those should not be the same thing. So, control-wise, I should be able to scale these axes independently of this and not have to use these controls to do it. Made it a real freaking nightmare trying to get this thing to basically work. Anyway, but that kind of corrected the problem. And another thing I tried doing, I'm running at a different frequency now, and that didn't seem to matter. As you can tell, I've changed the frequency here. I'm going up to higher and higher frequencies, but the curve still looks the same. In fact, geez, let's go up to multi-kilohertz. It's starting to affect the curve, at 9 kilohertz, but so but what's interesting is you start getting down to really low frequencies. You would think it would give better resolution, but it doesn't. For some reason, I haven't figured this out yet. It cuts it off, even though the waveform parameters should be the same. I know if I swept this with DC, because you can do this in like persistence mode, for some reason you just get less and less reading. Say at 20 hertz, you're getting a full reading, but I can't go lower than that. There's no capacitors in the system, not in my circuit, and not on the probes. I took that out of there. So, it does have some capacitance, but 30 picofarads aren't going to make a big difference, to a, in a circuit like this. There's no feed-through capacitors or anything on it, so that was the only thing I could think of. But see, let me try to take this back to DC. I'll probably screw everything up by doing this, but I'll switch to DC mode. Alright, where I got direct control. Okay, so that's set between 2.5. Okay, so sweat. So you can see here. Let me turn on. Let's see. Where did I do that? Turn on persistence mode. All right. So now I can come and basically by dragging this, I can sweep my own curve. Well, that's at DC. That's totally at DC. And I'm just doing that manually. So you can see the range I'm sweeping over. But yeah, I mean, it's like I said, it doesn't have a problem with DC. Well, why does that frequency cut out? So, at any rate, I'm really not sure what to make of that yet. But here, I'll turn persistence mode off again. I don't need it. And see, okay, now it's doing something different. Because it's messed up my measurements clearly. So, I don't know why. Again, the more bugs that it has in it apparently. Okay, yeah, it's got a real fucked up offset here. Well, anyway, I'm gonna dick with it some more. Cheers.